Good morning. Put my reading glasses on here. I have several of my board members from the Semiconductor Industry Association here this morning, including John Kelly of IBM, Lisa Su of AMD, and then tomorrow Steve Mollenkopf of Qualcomm and Tom Caulfield of Global Foundries are going to be speaking, so I need to see my script and get this right. It's a real pleasure to be here in Detroit. Bill Chappell, you still out there? I was actually born here in downtown Detroit, and I have fond memories of coming out here in the summers and spending time with my grandmother in her Oldsmobile coming down Jefferson Avenue into town. And she was a Detroit person. She bought a car every 3 years. As that was a good thing, the bad thing was that her cars never had air conditioning, so I remember those rides coming down Jefferson Avenue, being super hot, and a lot of life, a lot of activity on that road in this city, and it's great to see this city has come back so much since I was a kid out here spending summers with my grandmother. So I want to thank DARPA for giving me a few minutes to provide some industry perspectives on the importance of government action to promote the U.S. semiconductor innovation and leadership. It's great to see so many SIA member companies here. We represent SIA, Semiconductor Industry Association, represents 95% of U.S. semiconductor industry. So the semiconductor industry is absolutely vital to America's future. And we deliver a huge impact to this country. We employ about 250,000 people in the U.S. and support more than 1 million jobs, as you can see from this slide. U.S. companies dominate the global market, accounting for nearly half of the world's semiconductor sales, and it's been that way for decades. We also do about half of our manufacturing right here in the good old U.S. of A. Basically, we still make our stuff here, and we do that in a big way. Due to our strong domestic manufacturing footprint, semiconductors are America's #4 export. In fact, we surpassed cars last year, sorry, Bill Chappell, as an export. And our sector invests roughly 1/5 of its revenues back into R&D, making us one of the most research-intensive industries in the world. This investment is what really powers America's global leadership in semiconductors. But the importance of the semiconductor industry and semiconductor innovation goes far beyond these tidy data points. As this group knows, semiconductors enable the technologies that will help determine the future of the U.S. economy, U.S. technology leadership, and national security. Chip-level innovation is driving AI, quantum computing, next-generation telecommunications networks such as 5G and 6G. These technologies, in turn, are advancing a range of growing applications and markets, including autonomous vehicles, IoT, and advanced manufacturing. The U.S. must remain leader in these technologies. We must have, as Bill Chappell was talking about earlier today, we must have a positive innovation-first stance to do this. That's why this meeting is so important, and that's why the DARPA ERI is so critical to this country. So, despite the overall strength and promise of the U.S. semiconductor, we face numerous challenges in maintaining our leadership position and harnessing the must-win technologies of the future. John, Lisa, Mark, and Bill have touched on and focused on a lot of the technology challenges we face, challenges and opportunities we face. I'd like to highlight some of the market and policy challenges and opportunities we face. One short-term challenge is the semiconductors market's famous and notorious cyclicality. Following record sales of $469 billion last year, that's approaching $500 billion, we are enduring one of our periodic troughs this year, and annual sales are estimated to decrease by something in the tune of 12% in 2009. For 2019. Fortunately, the long-term market outlook is bright, thanks to the new growth markets I've mentioned a moment ago and others have touched on this morning. But we also face several longer-term systemic challenges related to talent, trade, and technology. Our talent challenge is stark. About 2/3 of graduate students in STEM fields at universities are foreign nationals, and not enough young Americans are pursuing STEM studies. I like to say, I'm very proud to say that my 18-year-old boy is going to enter college this fall, and he got an 800 on his SAT math score, and he's going to be doing liberal arts and staying away from STEM, unfortunately. So this disparity is particularly large and growing among computer science and electrical engineering grad students, as you can see by the divergent lines on the graph. It's rather startling. As for all those smart students who get CS and EE degrees from our world-class universities, our immigration system does an efficient job of chasing them away when their studies are finished back to their home countries into the arms of competitors. Our industry has thrived in part because we have benefited from attracting the best and brightest from around the world. But this may not continue without swift action to fix our country's high-skilled immigration system. We have also faced significant challenges related to trade, which is a critical issue for our industry since more than 80% of U.S. semiconductors sales go to overseas customers. First, trade with China poses obvious risks to our industry. As shown in the chart, China is the U.S. industry's largest market. It's also our fastest growing market. At the same time, the Chinese government is investing heavily to establish an indigenous semiconductor industry, which is fine. But we've seen how this kind of state-driven effort has unfolded in other industries, and while semiconductors are unique in some respects, we cannot be complacent. Export controls and other restrictions on technology transfer also continue to be a challenge. Our position is that as the U.S. government seeks to ensure our country's national security, it also should double down on helping us to ensure our semiconductor industry stays in the pole position. The tariffs imposed are another problem for us. If we are going to stay innovative, we can't have tariff walls being put up pell-mell. And all this loose talk of disentangling key economies is simply unproductive and unhelpful. Okay, let me turn to the technology challenge a bit in terms of policy, which is the focus. The technology challenge is the focus of this summit. As it becomes vastly more difficult and costly to maintain the breakneck pace of semiconductor innovation, industry, academia, and government must intensify research partnerships to explore new frontiers of chip technology. John Kelly was really hitting very hard on that this morning. Much appreciated. So we've identified some big challenges, but what are the solutions? Well, to begin to answer this question, SIA this spring issued a policy plan called Winning the Future, a blueprint for sustained U.S. leadership and technology leadership. And there's the beautiful cover of that thing. The blueprint sets forth a strategy to help the U.S. semiconductor industry pedal faster so America stays in the lead in the must-win technologies. This policy's prescription rests on 3 pillars: research investments, work development, and trade and open markets. I'll use my remaining couple of minutes to focus on the research and technology side of things. We all know research and innovation are the lifeblood of the semiconductor innovation, of the semiconductor industry. 2 important points about the American research enterprise. First, our industry's large R&D investment is complemented by the great efforts of DARPA, DOE, NIST, and the NSF, and other government agencies to further research in material sciences, engineering, chemistry, computer science, and other fields. Second, our companies are fierce competitors in the marketplace, each working to out-innovate and out-design each other. Research led by the federal government can bring these fierce competitors together alongside academia and the nation's greatest scientists to tackle research questions and progress no single company could manage on its own. Our industry was founded on the strength of this enduring partnership between government and industry. This partnership and the overall American research enterprise is the envy of the world and has yielded monumental dividends, helping to drive a remarkable pace of innovation and sustain Moore's Law for half a century. Unfortunately, as you can see from this slide, federal investment in research has been stagnant, while our global competitors are investing heavily. To be blunt, we risk ceding our technology leadership in the absence of a renewed commitment to investing in research. SIA's policy blueprint calls for tripling investment in semiconductor research over 5 years and doubling investments in related research in fields such as material science and computer science. Many have told me since we published this report in the spring that even these goals are not ambitious enough given the challenges facing us. The ERI and programs like it are critical to the future of the industry and precisely the type of government-industry partnership needed to sustain U.S. leadership. We applaud DARPA for launching this program 2 years ago, and we appreciate the leadership of DoD in launching the MINSEC program. Similarly, the DOE Office of Science is leading on critical programs in exascale computing, quantum computing, and material science. And NSF and NIST are also driving important programs on nanoelectronics and other basic research areas critical to us. To build these important efforts, I'd like to suggest, I'd like to suggest that the U.S. government consider establishing a national semiconductor research initiative to better ensure closer coordination among agencies and drive towards ambitious goals to keep our semiconductor industry the leader of the pack for the next 50 years. SIA and our industry are committed to partnering with the federal government to advance policies that strengthen U.S. leadership in semiconductors and the many technologies they enable. This effort is critical to our country's future, and with some very big challenges looming, now is the time to step things up. We cannot and should not let this opportunity pass. The U.S. semiconductor industry has overcome monumental challenges in the past. Working together, I'm confident we can do it again. So this summit is an important step forward, and I look forward to the discussions over the next couple of days. Thank you very much.